I have uploaded one image that was a problem from old edition missing in the new edition. So particle was in the ground state, so okay, of a harmonic oscillator with so frequency equal to omega. Okay, yes, speak out. Yes.
2.40 problem.
Wait, I'll do that problem. 2.40. I'll do that one. Okay, I'll do that one. Omega. Again, I'll give the approach. Okay, you just do that one. The image that I have uploaded to Google Classroom. Okay. So omega, for omega natural frequency, again it was in the ground state. Okay, psi naught is equal to m omega by pi h bar raised to 1 by 2 e power minus m omega by 2 h bar x square. Okay, with energy E naught is equal to half h bar omega. Okay, it was in the ground state. Now what happened is spring constant is quadrupled.
So 1 by 2.
1 by 4 normalization factor. Yeah, spring constant is quadrupled. Omega proportional to root k. Do you remember? Root of k by m. Mass remains same, but spring constant is quadrupled. That's why omega will become 4 omega. Sorry, 2 omega, isn't it? So this is old linear harmonic oscillator. Now new linear harmonic oscillator. Okay, so this is 2 omega. Okay, so that's why again look at here. The question is, what is the probability of getting half h bar omega after making this kind of change suddenly? Look at here. We are making this change in such a way that this state is momentarily unchanged. This wave function is momentarily unchanged. Exactly the same question that we have faced in case of box, where walls are suddenly moved outward, isn't it? So again, but wave function unchanged. Okay. So now again, new linear harmonic oscillator. Again, the question is, what is the probability of getting after making this change? Okay. Look at here. Let me first see the question. After making this change, wave function is not changed. That's why our initial state is this one. But our system is this one. Initial state is this one. Initial state can be any state, isn't it? We have seen in the 1D box problem, isn't it? That is the initial state. So, but our new linear harmonic oscillator, it's Hamiltonian. Everything is changed now. Its potential, everything is changed now. Okay. So that's why in case of new harmonic oscillator, it has a frequency 2 omega. That's why this En new, that's equal to n plus half h bar into 2 omega, new eigenvalue. Now he is asking what is the probability of getting h bar omega by 2. What is probability of getting h bar omega what is probability of getting 3 h bar omega? He didn't ask, I think. Is that okay? Now first write down these possible values. What is E naught new? H bar omega. What is E naught? E1 new. 3 h bar omega. Check this out. And so on. There is no eigenstate with energy this one, h bar omega by 2, isn't it? Measurement outcome should be one of the eigenvalues, isn't it? There is no eigenvalue, energy eigenvalue with value h bar omega by 2. That was old ground state actually. You are doing the measurement on this system with initial state this one, isn't it? You are doing the measurement on this system, new LHO, with initial state this one, isn't it? So that's why there is no what you call possibility of getting this one. This probability is 0. Can you write? Isn't it? Don't do any integral here. If you do integral, you will get some non-zero. Initial state, final state. If you take something, you may get some non-zero value.
I do that one.
But think over it. Your measurement outcome. These are postulate actually. I didn't mention that it is postulate. You just see Jetili second chapter, postulates of quantum mechanics. Okay, these are postulate actually. Measurement outcome should be one of the eigenvalue. Is that okay? So there is no eigenvalue of h bar omega by 2. There is no possibility of getting this one. Is that okay? Yeah. So again, this is not by any integral. This answer is not by any integral. It is by the postulate. Are you getting my point? Yeah. Now, what is the probability of getting h bar omega? Yeah, you may have probability of getting h bar omega. H bar omega may be the possible outcome. Why? It is one of the eigenvalue. Okay. Now, to get probability of h bar omega, now I need psi naught nu. I need psi naught nu. Now look at here. Most of you, when I have taken interview session, what you are directly, I am not asking what is the probability of getting ground state of new LHO. I am asking probability of some particular energy. First you should see energy, then you should write corresponding wave function, isn't it? You are directly writing final ground state. How do you know that h bar omega is a final ground state? Only after writing this one you will get to know, isn't it? Are you getting my point? I am not asking final ground state. If I ask final ground state, you try to write final ground state. I am asking some h bar omega. First observe which state it is, isn't it?
But h bar omega
Is a ground state, that's true. But without writing this one, how do you get to know that again ground state is h bar omega? Or whatever I am asking, that is ground state.
Okay, if someone will ask 3 h bar omega,
Like that, isn't it?
then we will go to first
Yeah, that's what I have designed over there. Is that okay? So that's why I asked what is the probability of getting h bar omega. Now observe that h bar omega is a ground state. Now write down this one. But this because I need this one. Initial state, this would be final state after measurement, and inner product mod square, isn't it? What is this one? m2 omega by pi h bar raised to 1 by 4 e power minus m2 omega by 2 h bar x square. Isn't it? Now this would be final state. Now take inner product. Minus infinity to plus infinity. Psi naught I star. No, actually final wave function star actually. It doesn't matter, okay? You will see later. Isn't it? Psi nu final state star psi I naught dx. Psi I naught this one. But in this case, look at here. Range of this one is also minus infinity to plus infinity. Range of this one is also minus infinity to plus infinity. Range will not change, okay? So that's why this mod square, I need to take mod square of this one. This one multiply, this also normalized. Remember, while dealing with this one, these two should be individually normalized. You are changing omega by 2 omega. That will not take it out of normalization. Or replace omega by omega dash. Call omega dash as 2 omega. Is that okay? Wait a second, let me do this integral because I felt we can explore some normalization condition. Let me check that out, okay? So integral minus infinity to plus infinity m omega by pi h bar. Can I write 2 raised to 1 by 4 outside? This is probability amplitude, okay? Not probability, okay? Raised to 1 by 2. What will happen is e power minus 3m omega by 2 h bar, because 1 by 2 plus 1 would happen. 3 by 2 will happen x square when you multiply these two, okay? Dx, okay? What I am thinking is multiplying dividing by 2. Multiplying and dividing by 2. 2 into 3, okay? No, it is not required, okay? It will not take that much time to do this integral. Don't do this one. Let me try, okay? Because I am quite crazy about that one. Doing that one, okay? Maybe this kind of idea may work in some other lengthy integral, isn't it? That's what I am doing. What I am doing, minus infinity to plus infinity, m omega by pi h bar raised to 1 by 4 e power minus 3m omega by 4 h bar x square, okay? M omega by pi h bar raised to 1 by 4 e power minus 3m omega by 4 h bar x square. M omega by 2 h bar. One more 2 is there. 3 by 2 is the extra term.
Sir, root pi by 8.
Not required, okay? This step is not required. Yes, speak out. Root.
Sir, root pi by 8 directly.
Yeah, you can do. That's what I'm saying. You can do. That is the easiest step, okay? But I'm quite what you call. Let me do this one, okay? I mean, this step is not required, okay? Just I'm doing it myself, okay? Now what I'm thinking is, along with omega, you have 3 by 2, that is extra term, isn't it? I need that 3 by 2 term here. I have to divide by 3 by 2. I need that 3 by 2. I have to divide by 3 by 2. 1 by 3 by 2 whole power 1 by 4 square under root. And if I take that factor, okay, this will be normalized. Not required, okay? But maybe this idea can be generated somewhere else. Are you getting my point? What I'm thinking is, again, in place of omega, I have 3 by 2 omega here, isn't it? When I compare this one. So that's why what I do is, I'm going to take m 3 by 2 omega. I have to divide by that factor, isn't it? 3 by 2 power 1 by 4, isn't it? Then I'll do m 3 by 2 omega, isn't it? Then I have to divide by that factor. Now this factor came. Now this is, so just replace this 3 by 2 omega with some omega prime or double prime or something. This will look exactly like this one now. Is that okay?
Okay.
Maybe this kind of idea you can generate in some other problem. Root of 2 by 3. Am I right, anyone? And probability of getting h bar omega, it's mod square of this one. So, root 2 root 2 by 3. Am I right or not? Anyone?
Yes.
Right, isn't it? Maybe somewhere else. But look at here. You need to learn this kind of step, isn't it? How I made that one look like this one, isn't it? 3 by 2 omega is replaced by 3 by 2 omega. M 3 by 2 omega by 2 h bar x square. Is that comfortable now? M 3 by 2 omega by 2 h bar x square. Check this out. Now this is exactly same as this one, normalized. Psi star into psi dx minus infinity plus infinity. Ground state, isn't it? That's what I was trying, okay? Just some manipulation. No, but it is not required here. It is very simple integral. Root of pi by coefficient of x square, okay? It will get cancelled. You can do it very easily, okay? This is the answer. Now, what is the probability of getting 3 h bar omega? 3 h E naught nu is equal to h bar omega. E naught E1 nu is equal to 3 h bar omega. What is the probability of getting 3 h bar omega? Quickly, anyone? 0. Why?
You want to know what the root will be?
Yeah. Psi 1 nu, it will be odd function. Initial state is this one. But system is this one, okay? You are doing the measurement on new system, but initial state is this one. Final state will be this one. If 3 h bar omega comes, am I right? Then final state is odd function, initial state is even function. Your limit is minus infinity plus infinity. There is no probability. Integral is 0. It's not because of any postulate, because integral is 0. Is that okay? Inner product is 0, okay? So try to do this one. But again, the same question is generalized in some Weichel problem, and that is also asked in some JEST or TIFR question, okay? 2.40. 2.40, okay? Quite lengthy problem. I got some idea, so try to do this. So psi of x comma 0, that's equal to a into 1 minus 2 into root of m omega by h bar x into x, the whole square, e power minus m omega by 2 h bar x square. This is not any stationary state. You will see later also, okay? This is not any stationary state, okay? We shall see later. Again, I am going to introduce that one. The time, yeah, 6:28. So now look at here. Again, try to write this one in terms of what you call initial state, okay? To write that one, you need to know what is psi naught. Psi naught, you know that one, am I right? M omega by pi h bar raised to 1 by 4 e power minus m omega by 2 h bar x square, isn't it? What is psi 1? Yeah, x into that one, but what is the normalization factor? Yeah, any idea?
Under root 2m omega by h square.
2m omega by h bar, am I right?
Yes, sir.
E power minus m omega by 2 h bar x square, okay? Now, psi 2, let me guess, this will contain 1 by root 2 or root 2 factorial extra.
X factor.
Am I right? Oh, yeah, here x should be there, isn't it? Yeah. Yes. X into e power minus m omega by 2 h bar x square, x into Gaussian, am I right? So psi 2, it will have one more 1 by root 2 factor, okay? M omega by pi h bar raised to 1 by 4. This term will be there. Okay, anyone? Can you quote?
Yes, sir.
1 minus
The 2m omega.
2m omega? So correct this one. I don't remember. Correct this one. 2m omega by h bar?
Sir, 2m omega square minus 1.
This square minus 1.
Yes.
I think one more factor would come here, isn't it? No. No?
1 by root 2. 1 by root 2.
1 by root 2. 1 by root 2 is the factor. I think 2m omega by h bar x square minus 1. So tell me correctly, okay? Because again, otherwise we will stuck in the middle, okay? E power minus m omega by 2 h bar x square. Check this out. Right or not?
Yes. Yes, sir.
Perfect?
Yes.
Actually, it should be 2 factorial, but that's equal to 2, okay? Now what I do here is, look at here. Let me just rewrite this one, okay? A into 1 plus 4m omega by h bar a square plus b square minus 2ab, am I right? 4 root of m omega by h bar x multiplied with e power minus m omega by 2 h bar x square, isn't it? Check this out. A square plus b square plus 2ab. Is that okay? Now look at this term. I'll take that e power, that Gaussian term inside, okay? What will happen? What I need here is, look at here, along with Gaussian, I have x square term, okay? So, but I have 4m omega by h bar x square, okay? So, again, well, let me multiply this one with 2. Again, I have minus 1 term. I need minus 1 term over there, isn't it? So, I'll just add and subtract something. I'll just manipulate this one so that I can fit this one there. Is that okay? That's what I'm feeling comfortable. Wait a second.
Sir,
Yes.
another way you can do that.
Yes. I think you have done yesterday, isn't it?
Yes, sir.
Yeah, wait. Again, let me try in a new way, okay? In my way. Again, later you do in your way, okay? So that's what I'm saying is 4m omega by h bar x square, I need minus 2. Isn't it? If you multiply this one too. Okay? But plus 1 was there, minus 2. I should add plus 3. Am I right? 1 is replaced by minus 2 plus 3 because I need this factor. See here. And that factor can be multiplied with Gaussian later. So you will understand. Wait a second. Now what factor remain? Minus minus 4. What I do here is root of 2m omega by h bar. I'll divide by root 2 because I need that factor. Isn't it? Isn't it? Actually, I took a lot of space for this one.
One step into this. M over by 1 by 4.
That, look at here, that is required for this term as well as this term. I'll just throw in that term. The whole thing can be multiplied with one constant. I told you, isn't it?
Okay.
Without changing the individual weightage. I'll just throw in that term. Later I'll normalize. Isn't it? I think I have taken one idea, isn't it? If A vector is equal to AXI cap plus AY j cap, if you multiply by a constant, its direction will not change. Later you can make it as a unit vector, isn't it? Like that. If you multiply the whole factor with a constant, it will not change anything. Okay? Look at here how I modified that one. Is that okay? So now look at here. A into let me put in big bracket. Actually, I don't have space actually. So 2 times, and what I do here is I need 1 by root 2 also, isn't it? Here 1 by root 2, that's the extra factor. So multiply by root 2, divide by root 2. So this one multiplied with this quotient, I'll throw in this factor through the whole term. So that will become a root 2 into psi 2. Wait a second, I did one mistake somewhere. One more 2 factors should be there, am I right? 2 factor 2 I have to take outside. Be careful because I'm out of space here, okay? Otherwise you better do one more step, okay? So 2 root 2 psi 2 plus 3 into psi 1. I'm throwing in this factor. This was extra thing needed in all 3, but I have just thrown that factor, okay? I hope you got that idea. I have done in case of the sine cube theta problem. Yeah, exactly same. Minus, this factor is already there. This factor I have thrown, so everything is okay. 4 by root 2 psi naught. Is that okay? So psi of x comma 0, okay, that's equal to, yeah, speak out.
Psi 1 in the last.
Yeah, this was psi 1, this was psi naught, isn't it? 3 into Gaussian, that was psi naught, that is psi 1, okay? So that you got A times 3 psi naught minus 4 by root 2 psi 1 plus 2 root 2 psi 2. I don't like to have any denominator term. I'll throw in one more factor. Why not? Is that okay? Because in the later step, you can avoid even one taking LCM. That's what I'm saying. Okay? A 3 root 2 psi naught minus 4 psi 1 plus 4 psi 2. Check this out. If I multiply by root 2, the whole term can be multiplied with some constant, okay? Not individual term. If you multiply change individual term, individual coefficient, it will become some other state. Is that okay? Speak out. Am I right?
But I mean, eliminating the option.
No, that we need to have option first. You should see the option, how they design question. Am I right? Now, mod square. Yes.
The A should not be longer A, it should be A prime.
Okay, yeah, you are absorbing those things, isn't it? Yeah, that's okay. I have thrown in some term, I have divided by some term. Okay? It will be some other ray. That's exactly correct, isn't it? I have thrown in that term. It should be divided by m omega by phi h bar raised to 1 by 4. Am I right? Then I have multiplied by one more thing. This should be this should be a prime. This should be a double prime. Whatever. Okay? The same symbol. Is that okay? Dare to multiply the whole term with some constant. That's what I'm saying. Whole term, not individual weightage don't change. I told about that vector idea, isn't it? If you multiply individual term, the direction will change. The direction have got physical meaning here. Is that okay? You will understand more in what you call linear algebra. Okay. So 9 into 4 plus 16 plus 16 is equal to 1. What is A? 1 by? Speak out. Speak out. 70? 60? 68. Any root? You can write off root of something. Quickly tell me. No, you can. Not divisible by 4. Not divisible by 4. It should be divisible by 4.
In the first step, you could rationalize here in the left side.
Yes.
Left side, sir.
Yes.
In the first step, you could rationalize this second term, second side, psi 1. Psi 1 term. Rationalize this.
No. What I'm saying is, so since I may get into some LCM term here, I multiplied whole thing by root 2 and I have rewritten here. What I'm saying is this state is same as this state, maybe some different thing that we are finding here. Isn't it? So this will help you to simplify the step, isn't it? What is root 68? How do you write root 68 quickly? So get me. 2? 2 root 17. Okay, that will help you here. Okay, so psi of x. Yes.
Sir, 9 into 2, sir. 3 root 2 square is 9 into 2.
9 into 2. Yeah.
It is right. No, sir, it's correct.
9 into 2. Yeah, that's correct. 9 into 2, not 9 into 4. Yes, tell me. A equal to 1 by root. What is?
But sir, we have taken 1 by root 2 term, right?
What I said here is you have this one, isn't it? When you take mod square, what will happen? 9. I think you again this mod square you can do. Don't multiply. You do as it is. Do as it is. But what I'm saying is I'm trying to give you some ideas here. Okay. Maybe that step may be easy, isn't it? Again, mod a square 9 plus 16 by 2 plus 4 into 2, 8. Yeah, so this is easy. But what I'm saying is, if suppose there are some lengthy denominator, try to eliminate that one by multiplying with the denominator, whole term. Is that okay? Whole term. Okay, any problem on YouTube?
No, sir.
Why this laptop is not switching?
Sir,
Yes.
sir, if you square it 2 times and multiply the term.
Which one you are squaring?
Sir, psi 0 square.
Now here you are multiplying by 2, that's okay. But here also you should multiply by 2, that's it. I think this is okay. Again, what is A? Speak out. 8 plus 8 plus 9. 1 by 25? 1 by? A square is 1 by 5. Am I right? 1 by 5. Yeah. You can just substitute that 1 by 5, isn't it? 1 by 5. 3 psi naught minus 4 by root 2 psi 1 plus 2 root 2 psi 2. Whether it is right or not, somebody comment. Mridunal? Right, isn't it?
Right.
Is that okay? I mean, this is more easy because look at the factor. If suppose this factor was not there, I think you can't do this one, isn't it? This factor is there, isn't it? Try to manipulate. It will be more easier. Isn't it? I have done in very less step, okay? I might have stuck in some step, but I have done in a very less step. Look at here. Is that okay? And now this again mod psi square or mod square of individual coefficient, that will talk about probability, and you can find later function, everything. Is that okay? Yeah, do the later part. This is a qualitative argument, problem 2.41, okay? This is a qualitative argument. So that means he is asking about half harmonic oscillator, okay? So that means V of x is equal to half m omega square x square when x is greater than 0. It is infinity when x is less than 0. We symbolically draw like this. Is that okay? This is parabolic when x is greater than 0, okay? It is infinity when x is less than 0. It means particle cannot enter in this region. Is that okay? So now see this one, see this full harmonic oscillator. Half m omega square x square, okay? Draw the states, okay? Draw the states here, ground state, am I right? Isn't it? First excited state. Isn't it? Second excited state. Isn't it? Now look at here. What he is asking is, now what is the energy eigenvalues of this one? What are the allowed state compared to this one? Compared to this one, what are the allowed state there? Is that okay? Compared to that one, what are the allowed state here? Now this is x equal to 0 here, am I right? This is x equal to 0. Wave function is 0 here, am I right? In this region, your wave function is 0. Is that okay? That means wave function should start from 0 here, isn't it? Only the state which is equal to 0 at x equal to 0, they are allowed. Exactly similar to particle in the box, am I right? We enforce that condition. At x equal to 0, wave function should be 0. Do you remember the derivation? Okay. So since wave function is 0 in this region, wave function should be 0 at x equal to 0. It should start from 0. Continuity of the wave function demands that one. Speak out. Is that okay? So that's why this state is not allowed. Psi naught of this one, this is not allowed. Psi 1, psi 2. Okay? This state is not allowed because this state is not 0 at x equal to 0. Gaussian, am I right? But this state is 0. This is allowed. This is not allowed because this state is non-zero at x equal to 0. Isn't it? So that's why this state is allowed. Psi 3 is allowed. Psi 5 is allowed. Okay, n equal to odd, that kind of states are allowed. N equal to even, that kind of states are not allowed. What is the ground state here? The ground state, if you draw, look at here, ground state wave function, if you draw, it will be like this. Wave function is 0 here, okay, it will be like this. This region is cut off. But this will, again, if you keep this one, it will not satisfy continuity because this side wave function is 0, this side we should start from 0. Whatever the state which are starting from 0 here, they are allowed. Is that okay? So can you draw next state similarly? Is that clear? Any question? So what is the corresponding? Now this is the ground state of this one. What is the minimum possible energy? This state has a minimum possible energy. That is, this state is not allowed here. So that's what is the energy for this one? Psi 1? Ground state. E ground state. What is the energy correspond to psi 1? 3 by 2 h power omega. What is the first excited state here? Can you guess? Can you plot this one? Start from here. Odd function. Okay, so that the first excited state, it will be like this. Is that okay? This is first excited state. First excited state. That has energy psi 3, correspond to psi 3. What is the energy? Speak out. Like that it will go. We will solve this one, okay? We will solve this exact energy in case of WKB method, okay? And there are questions like, in TIFR or somewhere, they are asking what is the wave function actually. They are asking you to choose one of the wave function, allowed ground state wave function. Don't choose this one because this is not allowed, because this side, if potential is infinity, means particle do not go there, isn't it? That is the meaning. Particle will not go there, isn't it? If particle is not going there, wave function is 0 here. That's why wave function should start from 0. It should start from 0 here. Continuity of the wave function demands that one. Is that okay? Wave function should be always continuous. That's why this is not allowed. This is not allowed because these are the wave function which are non-zero at x equal to 0. You can just cut off this part, you can take this wave function. You can just cut off this part, you can take this wave function. Speak out. Question. Is that okay?
So, sir, n plus half will be inside will be.
No. Now, if you want to write in terms of integer, you better to redesign that one. Am I right? Again, En here is equal to 2n plus 1 plus half. N should be equal to what? Am I right? H bar omega. Isn't it? N will be equal to 0, 1, 2. Check this out. If you put n equal to 0, half plus 1, 3 by 2 h bar omega. Isn't it? If you put n is equal to 1, what is this one? 2n plus 1, 3 plus half, 7 by 2 h bar omega. I have just redesigned. Earlier you had En is equal to this one, En is equal to En plus half h bar omega. Isn't it? En is equal to 0, 1, 2 and so on. Now only odd terms are allowed, odd n's are allowed. Now in place of this one, I will make 2n plus 1, which is always odd. 2n plus 1 is always odd, you know that? That's it. Now you got the states. Is that okay? Where n starts from 0. I have just redesigned that one. Okay? Yeah.
Particle was
Outside.
classical.
Yeah, that I haven't quoted actually. That's very good question. Thank you for that. No. Wait a second. No, that integral we can't do, I think, that easily. Only Gaussian infinite integral we know, okay? So, half m omega square x square, okay? If particle is in the ground state, okay? E naught. What is E naught? Half h bar omega, am I right? Now, okay, these are classically allowed region, isn't it? Are you getting my point? Can you write down this point here? At this point, your half m omega square x naught square is equal to E naught, am I right? That's why x naught is equal to plus or minus root of 2 E naught by m omega square.
Classical turning point.
Classical turning point, am I right? So this is equal to root of 2 E naught. I better substitute this one, E naught. What is the E naught? Root of 2 into h bar omega by m omega square. H bar by root of h bar by m omega. So that's why this point is root of h bar by m omega. This point is minus root of h bar by m omega. Plus x naught minus x naught. Okay. Now look at here. Classically, if particle have got this energy, particle should be stuck within this region. It should not go beyond that one. If it goes beyond that one, your potential energy higher than the energy of the particle. That means kinetic energy is negative. If potential energy is higher than the energy, kinetic energy would be negative. Is that okay? That will never happen. We call this one as classically allowed region. Okay? This region, we call this one as classically allowed region. This region, classically forbidden region. But look at the mod sign of square. Look at mod sin of square, look at here. You have finite probability of finding the particle root of h bar by m omega minus root of h bar by m omega. You got probability of finding the particle outside classically allowed region also. Is it? That is the difference between classical and quantum. I forgot to quote this one actually. Not only energy is discrete here, you have probability of finding the particle outside classically allowed region. How I sort this x naught, look at here, at this point, okay, at this point, my energy should be equal to potential energy, am I right? At this point.
Yes, sir.
Just substituting that one, solving that one, I quickly got that one, okay?
But sir, it will only happen when we have a finite potential.
Why are you thinking like that? This potential goes to infinity actually.
That wave function,
Huh.
transverse wave function, that will be goes to infinity, right?
Yeah, it is touching to 0. When x goes to infinity, it will go to 0. This is normalizable function, am I right? Mod psi naught square. Normalizable function, isn't it? It goes to 0.
That is a converting rate function. Okay.
Is that okay? It is not it is normalizable function. But this mod psi square, it extends outside this region also. Isn't it? You can find the particle in the region, okay, correspondingly that may be negative kinetic energy classically, isn't it? Classically forbidden region. That can happen in quantum mechanics. But you will not observe any negative kinetic energy, don't think like that, but you will observe particle there also. Is that okay? Anyway, we are not going to find the position of the particle in lab. So that's a different story, but while building up the theory, we should take care of each and everything, okay? So now what he is asking is find the probability of finding the particle outside classically allowed region. Outside this region, okay? So I need area, I need like this, minus infinity to minus root of h bar by m omega mod psi naught square dx plus root of h bar by m omega into to plus infinity, this one to plus infinity, mod psi naught square dx. Rather than writing this one, I can write as 1 minus integral minus root of h bar by m omega to plus root of h bar by m omega mod psi naught square dx. Am I right? This area is equal to 1 minus this area because total area under the curve is 1. Am I right? That's why this area is 1 minus of outside area. Sorry, again outside area is 1 minus of inside area, that's it, okay? That you can write like this also. But this integral can't be done, I think he might have also looked into some integral tables, okay? But better to remember this one, this question was asked in some exam. What is the percentage of finding the particle outside this region?
Percentage.
They are asking in percentage. In some exam they are asking because you can't do this integral in exam hall. Gaussian finite integral we can't do. Is that okay? What is that percentage? 16% outside the region? Anyone? 0.16? That you better remember, okay? I mean sometimes they ask question without thinking that whether it can be solved at that instant of time or not, okay? 16% of finding the particle outside classically allowed region. That probability is low, but that probability is finite, okay?